Okay. Hi there, everybody. We are recording coil data with JC, Jacquie Figg Don, Cary and Whitney, and Carolyn Anderson is here with us. So we're all going to be learning and evolving our knowledge of how to properly put the coils together. Jacquie has a working car unit, which is exciting. She's gone from the MIP Peru Keshe manufacturing and went and built her own units. Right, Jacquie? I should put better. And and you've gone from what, 25 to 35 to 56 miles to the gallon?
52 miles to the gallon so far. Yes.
Diesel. And we want to be teaching the car units, and I don't even have one on my van yet. We're working on getting that done, and Carolyn will have one on hers as well. And then we're going to also be teaching the power units. So we need to expand our knowledge, and we really appreciate you guys showing up. Don Greenfield in Saskatchewan, and JC and Jacquie Figg, and we are just blessed to have a family like this to help each other learn. And JC's high-tech knowledge is always hugely helpful. And as one of the Keshe Foundation tech guys. And then Don, I know you and I have done a lot of videos, and I love you have great technical knowledge anyway, and so you're working through your details as well. So we're going to learn together today on the coils and how to connect them well and right so we can have working units. And we can share that with other people, because as we do this tour across North America, we feel like we're on a really key mission to help a lot more people become aware of the Keshe technology, the plasma technology, and understand how to do it at home and become part of this wave that's going to carry us into the future. So thank you all for showing up. I feel so grateful. And yeah, let's go ahead, jump in. JC, you were sharing some things with Don a minute ago about how critical everything is. And
Well, Don had asked if the connections where you connect your wires together, if the style of connection matters. And to some degree, yes. You want a neat connection. I've seen everything from just ugly to amazing. The ugly ones work; they're not as good. Try to make them as neat and as compact as you can, and always keep the direction that you're turning your wires the same as your coils. So the helix is always the same direction throughout the entire system. That's
a really good point, and I've heard that in a lot of other situations as well. I've heard you say that a lot. Turn your wire the same direction that the coil is turning, and I think that's really key. We were wondering, Jacquie, did you hook your unit all together before you nano-coated it?
Yes, I did. You know what? I have a house unit with me that I've been working on. Hold on a second. And because it's basically the same thing as the car unit anyway.
Right.
And so you can kind of see that oh yeah, I can see. So you can see here where the connectors are. You see that? It's right here.
Hold it up just a little more. Yes, we can see that. It's kind of black, but
yeah.
Point things out to us, because we're really interested in the connecting coils and other things that we are not 100% sure about.
Of course, I got black gloves as well, which probably doesn't help. But anyway, here.
Very helpful.
I could probably throw more light in here, but okay. So yeah, as you can see, it's all one piece. And right here,
a little bit more, Jacquie. There we go.
Yeah. Mm-hmm. And so here we have the capacitors, and yeah, it's all one piece. And we made sure that it doesn't come apart anywhere. I mean, we tugged on it and made sure before we nano coated. So
how many capacitors and where are they at?
6, and they're here, and the little cage is down here. The little cage is the only thing that really comes out separate.
Okay. Video on that too.
Yeah. But then remember, in your car unit, you're not going to have those, so you don't have to worry about those.
Jacquie, can you hold that cage back up and just hold it so it really focuses on it, so that everybody can see it, and then when people watch the video later, they can also take a screenshot.
Yeah.
Sure. Okay. You know what? Here, look. Can you see that?
Yeah. And I do have a video with Dave of Peru explaining those capacitors as well. So
yeah. So, you know, the car unit, it's a lot easier. It's obviously only 2 bobbins and they're completely separate. So all you have to worry about are these connectors here.
So do you do all caustic or cold caustics?
Say that again, Don?
we can't hear you, Don.
Do you use cold caustics or steam process?
Steam.
Okay.
A lot. I had issues. Well, I didn't have issues. The copper had issues. I had solutions. Yeah, so the connector, I was explaining to Don a little earlier, the connector was probably the biggest pain to work with besides the design of the capacitors. But basically, I just cut like about 10 inches of whatever gauge I was working with the coils. So in other words, if I was working on the house unit, I used 14 gauge wire to make the connectors. If I was, when we made the car one, we used 16 gauge, so I used 16 gauge wire for the connectors. I have 18 gauge I'm going to be working with, and I will be using 18 gauge. And like JC said, it's wound in the same way as, you know, it's just like making a mini coil. That was it, you know, it's just the same thing. So what I did is I cut the wire at about 10 inches, and that was my mandrel. I then put that into the drill, and then very carefully cut another 10 inches. And I don't know if you can see here, I got a head of a drill right here. So if you imagine, I've got this little tiny piece of, you know, gauge coming out of here as the mandrel. And then you've got these little, you know, gaps in here. So I just put the wire in there, fold it over around the mandrel, and then put it through the hole and made 18 turns counterclockwise. And then it's a good idea at that point. You have to be very careful when you start off and when you end, because that's when the kind of clamping down occurs. So you want to be kind of careful as you go into it and careful as you end it. And then you want to terminate both ends. That's really all you have to do.
So what is that? Can you show us an example of what you're talking about?
Yeah, I probably don't have any. I didn't make all the ones that like were sample ones. I probably threw away. They were.
But you have them on that unit there, right?
Yeah, I have them on the unit right here. So let me
maybe separate one out and hold it for us.
Yes, let me have a look. Actually, let me have a look.
So what I found also is you can find piano wire at a hobby shop.
Uh-huh.
I found piano wire that is about the same. I've been using 18 gauge.
Mm-hmm.
Then I can turn those connectors around the hard steel wire instead of a soft wire.
That's much better idea. That's what we were talking about with Don earlier. Or even using a drill bit. So, you know, having a drill bit backwards, that would be a lot sturdier. Yeah, anything other than using the wire would probably be a good idea.
So these connectors then are separate units? You putting the wire through each side of it? Is that what you're doing, or is it just the end of one wire that's wound up?
Okay, so the way that Dave showed me how to do that is basically if you have your 2 double toroids, let's say, so separate. You've got your smaller one, your 81 coil, and you have your 144 coil one. Basically, the 144 coil one, you're going to make the pins bending down. The other one, you're going to have the pins bending up. And then the connector is literally going to go inside there. And you want them to kind of touch in the middle with the connector around it. And then
the connector is a separate item.
The connector is a totally separate item, yes.
Right.
Connected at both ends, yes. So we made like a bunch of those just to be able to connect.
Yeah, it's not necessary to do that. It's easy to do that. You don't have to put a whole lot of thought into your wiring systems. Do
you think the connectors are critical or not?
Well, yeah, they kind of are. You need to have it secure, but you also need to avoid a matter-to-matter connection. And you want to be able to put them together before you nano coat, so that when you are manipulating them, you're not damaging your nano coating in any way.
Okay.
And Whitney, what you're showing there is very similar to what I have, and I've put my
here on there.
Yep, I have put my connections on the ends of the wires themselves.
Oh,
so,
yours tiny. Are yours 18 turns? They don't look like they're 18 turns. They're
connections are not. No, this is just an example. This is just a sample piece.
Do the connections need to be 18 turns then?
Probably not.
Yeah, and that
18 turns, you don't have enough room for 18 turns.
Yeah, I agree. I think certainly on the car unit, I probably, maybe 10 to 12 would have been enough, and probably would have helped to have kept them out of the way. But the one good thing about having them actually as 18 is I was able to kind of grab two of them and pull them apart pretty well. So they don't touch.
Yeah. Armin has come up with another way to do this that's actually going to turn out to be a better system. And that is you put a winding on the end of each wire, but you leave a tail sticking out. So the tail of each winding goes into the winding opposite it. So it's actually a double coil connection.
Mm-hmm. Say that again, Tracy. I didn't quite get that.
Is that like half of a KML?
Who?
I'm sorry, I thought Keshe had up on his board KML connections. That's not something.
I'm not familiar with that. I probably know what you're talking about, but I don't know that term.
Just go ahead and just describe what you did one more time.
Well, on this coil here, this coil is actually part of what? Ooh, somebody's calling on Skype.
Yeah, that was mine. Sorry.
The wire comes out of the coil, and then it makes this little connector.
Mm-hmm.
With the new style connectors, the wire that goes through that would also have a coil. And the end of each coil would be bent parallel to the coil, parallel to the axis of the coil. So you have one of them going into one of the coils, the other one going into the other one of the coils.
Yeah.
So each connector would have actually two coils side by side, or kind of offset a little bit. Armin is really liking these connections because they're simple, they're easy, you can make the whole system modular, so you just plug it together.
You didn't put anywhere of that. Carolyn is thinking that's what's called a KML at the Keshe Foundation.
Well, and it may not be because you might have two coils. They were showing, a wire, you make the coil out of it, and then you have the tail at the other end, and then you take the tail and stick it through the coil and pull, and you take the start of the wire and you stick it through the coil and pull, so that you have both ends going through the coil.
Right. Okay. It's sort of similar.
Uh-huh.
Is it something like?
That's exactly it, Whitney. Exactly.
Okay, so then this end would go up through this, and you'd loop it, pull this one through that one, and loop it here.
Yes. Exactly. And that's an absolute solid killer connection.
That's why we have
Awesome. That's why we have her here, because she's brilliant.
She is.
Well, I saw her first unit and I was totally amazed. The workmanship was phenomenal on that device.
Yeah, she's really technically talented. It's amazing.
So then on the spacing between the coils here, let's see, do we have the two that aren't together?
Yeah. You want these?
No, the one that was straight.
Hold on.
So we've been working with 18 gauge, and normally I've made 18 gauge very smaller, but we made them fatter this time.
Okay.
Is this a good distance? Can you see how they're laying?
Let me get you.
Okay, that looks like about 1 millimeter. I would say 1 millimeter would be up on the large side.
On the large
Too large, huh?
Yeah, you want it a lot closer than that.
Too much room, right? Is that what you're saying?
Yes. I can't say it's too much room. It's still going to work. But
a little bit tighter. That's okay. And then
I think if we get them closer, you wind up with a little bit more efficient system.
Okay. So can it be smaller? So this is pretty thick. We could make these, because the 18 gauge is so small, we could have a smaller coil.
Yeah, well, 18 gauge is kind of an oddball size. You're really going to have to look, excuse me, you're really going to have to look to find the right type of mandrels that are going to give you the right sort of fit. The coils that I make, I use 14 gauge wire. My outside coil mandrel is a 3/8. My inside coil mandrel is a 6 millimeter. Okay, now 6 millimeter is about 30 thou smaller than a 1/4 of an inch. So, because 16 gauge wire is a 1/16 of an inch, close enough.
You said 14 gauge, but are you saying 16 gauge? You just said 16 gauge.
Sorry, 14 gauge wire is a 1/16 of an inch.
Okay.
Okay, 0.065. It's 0.64 and change, but we're not going to worry about that a little bit. So if you use a 3/8 and a 1/4 inch, then your outside of your inner coil and the inside of your outer coil are going to be size for size.
Yeah.
Okay, so we go a little bit smaller. Instead of 1/4 inch, I go to 6 millimeter, which is like 232 or something like that, which gives me just barely enough room to get that coil through. But it still slides. There's still space. And so far, the ones that I've made, they seem to be working pretty good. So I'm pretty happy with that. And it's easy to find 3/8 and it's easy to find 6 millimeter.
Yeah, it's important.
If you go to 18 gauge.
The 14 gauge, I was using like a 23/64. It was just one step smaller than a 5/8 bar. So with the 14. Yeah, and it was it fit really nice, but it takes a little bit of doing to find the right bars. We bought all of our bars together and we did tests on every kind of one that we had in the house. It was kind of fun.
Yeah, well, if you just take your inner mandrel diameter plus 2 times your wire diameter, it needs to be a little bit smaller than your outside wire diameter.
Yeah.
Or the outside mandrel, sorry. You need to measure your wire.
A little bit smaller so it just slides through. So, okay.
A pair of those are very, very useful.
Oh, yeah.
Okay, because that you can actually measure your wire, and the 14 gauge wire actually measures 0.062.
Yeah. 2.5. So, is the concern thickness of this? So if we make this same coil with 18, but it's smaller in diameter here, is that a concern, or making it?
No, it's the fit between the two coils. The sizes really don't seem to matter.
So JC, do you think 18 gauge will work on a car unit?
Of course.
On a house unit too?
Oh yeah, it'll work on the house unit. You won't be able to put as big a load on it.
Okay.
The trigger load, not the output of the device, but the trigger load.
And what do you think about the car?
The trigger load.
Well, okay. Just so I want to clarify for Whitney.
Okay.
When we say the Magrav's home universal power system can handle a 2,000 watt load, that's the trigger load. That's how much you put on the one plug as an output of that device. Your primary benefit is going back into your wall, not into your load.
Yeah.
Okay. So, and right now, what we're suggesting right now, which seems to be working really good, is just put a fridge on it.
Right.
You don't need no lamps, no extra stuff. Just plug it into your fridge and let it do its job.
Right. Probably because a fridge is running all the time and it has that sort of, I don't know, wind up, wind down kind of thing it does.
Yeah. Well, there's special properties with that motor and with the fridge. It's turning on, it's turning off. You're always constantly pumping that plasma field.
Right.
And that seems to be working really good. That's the recommendation right now is anybody that buys the Magrav, we tell them just plug your fridge in, don't worry about it. You don't have to do anything else. There's no other messing around to do. With the car unit, going back to your question, Cary, the two coils of the car unit aren't connected together. There's no electricity going through them at all.
Right.
Okay, so size of wire doesn't matter. You can make them this big. Okay, this is
Jackie, because do you have 14 gauge in yours or 16?
I have 16 in mine, but I bought a lot of 18 gauge. So
okay, this is wire from Cat 5 network cable.
Say that again.
This is wire from Cat 5 network cable.
Right.
So that's like 20 or something, 20 gauge?
26 or 28, something like that. It's very small. It measures 20 thousandths of an inch. But since there's no electricity going through it, you don't have to worry about the wire size. All you're worried about is the surface area of your nano coating. As on the car system, you've only got one of these two wires is connected. The other one is just looped over and sitting there, and same on the other side. So there's the size doesn't matter.
So that little one you just held up, is that 144 or the 81?
That's the 144.
That's what I thought. Okay.
There we go.
There's the 81.
It's a Barbie car.
So this was actually built for an electric motorcycle.
All right.
Which it's hopefully coming. My landlord's promised me this bike, and so I started building the stuff, and then a few things happened, and he had to go, and he's traveling all over the place right now. But when he gets back and things are stable, he says he's going to be picking me up this bike. And that'll be a test bed, because if I blow it up, it's like $30 to fix it. It's a cheap controller. I don't have to worry about it. But this is for the electric only systems as a test.
Cool. So we were thinking about seeding these things in resin, like a piece of organite.
Okay.
To keep them the vibration. I just can imagine this going down and having so much vibration in the car. You know, it's gonna rub off some coating.
Did you do yours with a glue gun, Jackie?
Yes, I did. And when I got back from Peru, I redid it. I plan on opening it back up and putting at least some kind of a washer inside, polystyrene washer or something, just so that in case it does come loose, that it doesn't actually connect. So a spacer, some sort of spacer.
Explain what you mean by that. I don't.
Hold on 1 second. Let me get the ABS caps. I'll be 1 second.
Yeah, you can also use silicone. Silicone appears to be relatively transparent to the plasma energy. I've used silicone spray on my plates to keep the nano coating on the plates. Another fella is making energy devices, infinity loops and that, and he just paints them with clear spray paint, and they still work.
So the silicone that you're using, is it just what you get from the hardware store to repair a tub or something? I mean,
that's what I'm going to be doing my car unit in, is just...
Because the glue has a melting point of 250 degrees, and I can imagine inside an engine you might actually end up melting your hot glue.
In Texas or something, you know, Florida with the...
Yeah, that's just the same stuff you build an aquarium with.
The other thing that we've been doing is dipping pens in this plastic that is it's a liquid plastic for coating your tools with.
Mm-hmm.
It's actually pretty fantastic.
Yeah, really like it.
I mean, how do you think that would work with the Magrav energy?
It would probably be relatively transparent. There's a post on Facebook just recently of a fellow who made up a paint pen, and he dipped it in sugar water, coated it with sugar like we coat it with cake. And his field is huge.
Yeah. Well, what do you think about dipping our car unit in sugar water before we coat it?
Try it.
I mean, it's obviously going to be making it more acidic, right? Because that's what it sounds like in the teachings with the balls.
Well, you're going to be adding energy to the system, and with the car system, that's a good thing. I want to go into a little bit of detail with this, something we saw in the plasma group earlier this week that'll clarify that. But I think it's probably going to be a good idea if it stays there. Now, if you coat them in sugar water, let them dry, and then embed them in silicone, it's not going anywhere. It'll stay attached to the system.
Yeah, don't.
The layering I've done is I've always put a little ash water and a little ash and a little sugar, raw sugar, into my dippings, and then heat them a little bit. Actually, some of the coils, I had the stove button was backwards, and so they got broiled.
So you're saying
even get the yellow
ash water, sugar, and caustic, or just ash water and sugar?
just ash water, sugar, and like the GANS. So I've been coating like 6 coatings, and put a little bit and some like sage and sweetgrass ash because of the power of those plants.
Right.
And are we doing mixed GANSes dipping on the car coils?
Yeah, it's the same. It's the same process as the host unit. Dave is using the same GANS as the host unit.
Okay.
No change.
What is that process?
You assemble it, you nano coat it, you coat it with your 3 GANSes, roughly equal mixes.
I know what it is.
Yeah.
We've got the same
Titanium and nickel and tungsten, and I want to use them.
Can we throw a little bit of those in?
Dave put a little bit of silver in one of his first ones, and it worked pretty good. I don't see any reason why not. I would avoid lead GANS because lead GANS is a gravitational sink, which is going to draw the energy back to itself. So unless you want to have that massive gradient, you would have a light GANS on one and a heavy GANS on the other, which is probably a really good idea. And again, this will go into an explanation I'll get into in a minute.
I know on the new hybrid unit, they were starting to layer the GANSes instead of having them all mixed. So I just wondered if we were being consistent with the mixed GANS process on the car unit as it's sort of been being done traditionally.
Yeah, well, Dave, is, from what I understand, he's just using the regular GANS. He's same stuff he's using on the house unit. And Lee Coates as well, he built a system, which I'd like to describe in detail. And I'm pretty sure he did basically the same thing. His GANS mix might have been a little bit different, but more or less the same thing. He was on the plasma reactor group, Rick Crammond's group, on Tuesday, and showed his car system, he did a nice job on it. And the one wire, because on the car system, you only connect one of the leads. You connect your gravitational lead goes out to the negative of the battery, and on the other coil, the magnetical lead goes out to the positive.
Yeah, makes sense.
On the negative side, where the gravitational is connected, your magnetical lead just doesn't do anything. It's just open. And what Lee did was he bent it back and made a loop, made a spiral right in the center of his coils, and he did the same thing for the other side. Nice. He wanted to nano coat the wire, the hookup wire, the lengths of wires. He had about the two sides. It was total about 5 feet of wire, maybe 6 feet of wire, 3 feet on each side. And he's like, I want to nano coat this wire, but he couldn't figure out how to do it efficiently. What he did was he just took the wires and hooked them together. Just the ends of the wires where you'd put them on the battery, he just twisted them together, and 3 days later, they're nano-coated completely.
Wow.
This thing is an amazing plasma source.
That's really cool.
Now, if we can make this a little more efficient by putting in a gradient, putting a heavy GANS on the gravitational and a light GANS on the magnetical, and on if you could do it with your individual coils, the springs.
So you're getting them to kind of push-pull with each other a little bit by having the different weights of GANS?
Exactly.
Why aren't we winding one gravitational and one magnetical then? So one clockwise set and one counterclockwise set?
No.
No.
No?
They're the same.
They're all clockwise.
Yeah, because the gravitational flows in one direction, the magnetical flows in the other. So by having them both the same, you're going to simulate one being backwards. Because one's going this way, the other one's going this way.
Okay, I'm not grasping that.
Well, the magnetical and the gravitational are counter-flowing energies.
Okay.
They flow in opposite directions. And if you were to take a coil, look at a coil, and track the flow in that direction, it's going to be clockwise. If you track the flow in that direction, it's going to be counterclockwise.
Okay, so the same coil is doing the same.
Because it's going both directions at the same time.
In other words, if you change the flow of the coil, they would actually be going in the same direction, and you want them going in the opposite directions.
Okay.
That's right.
That makes sense.
Right.
So, and then JC and Jackie, the connectors, we're talking about a multi-strand wire as the connector, right? That goes from the car unit to the battery. Is that correct?
Yes, yes. So inside the ABS, there's one little hole in there, basically. You connect on the inside, and then you just have a multi-strand coming out, yeah.
And is the multi-strand coated or uncoated?
Coated, yes. And I use, yeah.
And that's what JC,
really fast.
That's what you were saying, JC, naturally nano-coated once it was hooked up, right? So
Well, it wasn't even hooked to a battery. He just took the two wires and hooked them together and set it on a shelf.
Yeah.
And 3 days later, it was black right to the end. That's 6 feet of wire. I mean, with the Magrav system, it takes 2 or 3 weeks to go 6 feet.
So he's saying you connect the multi-strand wire to your coils that are already nano-coated, and it just nano-coats itself.
So you don't have the multi-strand nano.
Oh,
okay. It will just, okay.
And it will. It's just pumping out plasma. And as soon as you hook those two wires together, you made a loop of the plasma with a space between the two coils, which creates that flow. And that flow is huge.
And you don't even, you put the wire, the multi-strand on one set of coils, and you don't even hook it to the battery, and you still get, or are you hooking it all the coils together?
Assemble your system so it's a block with two wires coming out.
Yep.
Before you hook it up to the battery, hook the two wires together.
Okay.
Let it sit for 3 or 4 days. And if you strip back the insulation a little bit, it'll be black right to the end.
Wow.
Are you getting that?
Yeah, totally wow.
Raw wire, because it's got the coating and it takes a little bit. I actually have some 10-inch segments right now that are coated in there, and they're nano coated all the way through. But so we'll use those to begin with, but then we can buy raw stranded wire. So I'd buy like a 18 gauge. If I'm using 18 gauge round wire, I'd use 18 gauge of the other wire.
I think mine is, yeah. You know, you want it hooked up to the car battery. I would go probably a little heavier, but I got to say, I've been checking, and there's no heat on the unit in the car or on the wires. So it's, you know, I don't think really the gauge really that matters that much. It's not getting hot.
Well, you've got some heavy multi-strand, and I've got some lighter multi-strand.
Well, there's no electricity flow through this system at all.
Yeah.
It's all plasma.
You know, one of the reasons why this was created was because the car system with the typical Magrav car system with the capacitor in there, that capacitor is the only thing that's stopping your battery from exploding. If something goes wrong, boom, it's a short circuit, and the thing gets hot. You can have a fire. It works, yes, and when it works right, it works really well. But if it happens to go wrong, it's very dangerous. So we came up with, that's one of the reasons we came up with this system where there's no electrical connection between the two sides. There's no chance you can short your battery out.
Awesome. Nice to be doing this at this phase of the game.
Yeah. So what do you think about, Mike Nashif was just saying on another group call this week that to put a drop of blood in the center ball or a piece of hair, because when your car takes off, that's how you control it. You're connecting to the system. It makes sense that would add your energy to the system. It would like a key. It would give you the key to that car.
Do you have that in yours, Jackie?
No, I didn't spit in it either. I may have drooled with my tongue hanging out while I was doing the connectors, so who knows?
And is it okay as a central sun to use like a ping pong ball instead of a little plastic container?
Oh, you don't need anywhere near that much. The home Magrav units from the factory, they used a ball about the size of a paintball.
Okay. I don't know what size that is.
For my system, I'm going to be using little plastic cups about that big.
Okay. Oh, good.
Is that cup?
Great.
These are cheap. You can get these at the dollar store for a dozen.
Do you know what size those are? When I'm looking.
They're about 7/8 of an inch in diameter and about an inch tall.
No, I'm wondering, like when you buy the capacity, like it might say 1 ounce, a gram, a dram. Do you know what size that is?
Well, if I compare it to that, it would be 10 cc's.
Okay. All right.
Or sorry, 10 milliliters.
10 milliliters. Okay. Oh, good idea. I should go to milliliters. All right.
This is Canada.
Yes. Yeah.
We don't do that.
Oh, say that again, Don.
Oh, we can't hear you, Don, very well.
Is it mostly water filled?
Muted. You're muted.
Like a
You're
small
silent.
He's not muted.
I can hear him. Yeah.
For the center bowl, it's mostly GANS paste.
Yeah, we made a paste.
Yeah, but I thought the water is more charged, the plasma water is more charged to create the energy flow than the GANS itself.
Okay. It's easy enough to just have a couple of these, and one with water and one with GANS, and try them both.
I have some that's really concentrated, but we should dry it all the way down to more of a paste. Then I've got a thick liquid that's pretty dehydrated, but
the original plan was to use a thick paste, like toothpaste.
Yeah, it was like a paste.
Now, Dawn is saying that the water is going to be more effective. I can't say one way or the other. We haven't tested it, so I don't know. But it's easy enough. It's easy to switch them over and try it. If you're making a system that's not going in a car, it's going to sit on a shelf, and you'll use it for your GANS collection, for your energy source instead of a battery, which is something I'm going to be doing later on today. Then you can make it, you can make a fragile system that you can take apart and adjust and change a few things. So
Yeah,
it wouldn't,
both GANS and mostly water. And can you remember Keshe was saying that the GANS is not as powerful. The water is more powerful when it settles, and the clear water is up top. It's more powerful than the GANS itself.
okay. My triangular reactor, the wireless reactor, is basically that way. I've got a little tiny bit of GANS in the bottom,
Yeah,
very much like this.
yeah, that's what I was
Little
thinking.
tiny bit of GANS at the bottom, and the rest of it is water. And I don't, maybe I'm missing something, but it doesn't seem to be that powerful to me. Maybe I could have done something wrong too.
That's all I want to know. Yeah, okay.
So I know one thing that Dave had done was in the center, he put in a common tube. So just a little piece of piping of some sort, and he used one bottle instead of one bottle in each side. And you want to check with him, but I think it didn't work. That was the one unit that he tested, and it didn't work. So if you get that idea, you might want to check with him.
He was worried about the bottles coming loose, so he took a piece of plastic tubing that the bottle just fit in perfectly, and cut it the height so it spans the entire height of both containers, and drop the bottle inside, and the thing didn't work at all.
Right.
So you need two containers. You need two separate containers. You need that space between them.
Yeah.
I liked what Don was saying earlier. I was talking to Don earlier, and he explained that he had two GANs that he mixed together, and they kind of kept fluctuating between the two. I think it would be nice to see two different GANs, one on each side, to see what happened.
They weren't two GANs, they're both iron GANs. I just make two separate runs, and I was running out of jar space, so I drained off both water, put them both together, added fresh water in, garden hose. That's when I noticed after next morning it's separated. It kept going up and down, back and forth. Much the same way as CO2 cans I was making. I was pulling the yard together, and they would separate different layers.
Yeah.
Yeah, with the car unit, because of the demonstration of this plasma flow that we've seen, I mean, you could work really hard to make them both identical. They're not going to be identical. There's going to be a slight gradient between them. We know that gradient matters, so let's go way beyond. Let's make one a very heavy GANS, make your gravitational side, which goes to feeding the negative side of your battery, make it a very heavy GANS, and on the magnetical side, which is feeding the positive side of your battery, make it a very light GANS, and maximize that gradient potential between the two.
So would you suggest using silver as a heavier gradient?
I would probably go with, on one side, mostly copper oxide, on the other side, mostly CH3.
Okay.
And silicone.
We know they work.
Okay.
And we know they're not going to be a problem.
The two gradients.
CH3 is the lightest?
I don't know which one.
Yes.
heavier. I guess CH
on the
heavier for that.
Yeah.
or no,
Copper oxide of the big three, the ones that we normally use, and I prefer to use those ones because I know they interface with life well.
That's the lighter one.
Copper oxide is the heaviest.
Oh, it is.
Okay, copper is heavier than carbon. It's heavier than hydrogen. CO2 is in the middle, and CH3 CH3 is the lightest one that we have to work with. Until we can get like a helium GANS or a hydrogen GANS, and then we have a very light one. But I don't know how to make a hydrogen GANS yet.
There was something about putting this thing in resin with the GANS ball, and the heat from the resin. There's just something about how it makes a vacuum with that water inside the whole entire ball and the unit.
Entirely possible.
Yeah, there's that vacuum idea is, I think with the water, there's something important there. I don't really understand it yet, but.
Okay. Well, I've also got, this is attached to a motor, but I've also picked up these little glass balls.
Back it up a little. Okay.
Oh, wow. Oh.
They're just little tiny glass balls, and they got a little hole in it. This has got a piece of copper glued on the top just to seal it up.
Wow.
But we could use those as well. I mean, you don't need very much in that center section.
Cool.
So,
what are you putting for GANS into the gas tanks then?
Most people are using CO2. Put your CO2 GANS and add a little bit of CO2 GANS and some water in a little bottle and throw it in your gas tank. Make sure you seal it up with something that's gas safe, so it doesn't dissolve.
So you're actually not pouring the liquid into the gas tank?
I wouldn't, no.
Well, it will go away if you run it on empty. It will drain it out, and then you won't know when to put more in. I mean, that's one.
Well, no, the gas and the water is not going to mix unless you've got a moisture control in your fuel, like isopropyl alcohol.
Yeah, I was putting a little dehydrated GANS in there, very, just powdery, but it didn't seem to change things much.
No, probably not.
And I was just putting a pinch because I didn't want to. I was kind of cautious.
Yeah, you could do more or less. Good grief. You can do more or less the same thing by taking a nano copper, wrapping it around your rubber fuel line, and then putting a GANS paper on that and coating that with something like Seal-All or silicone.
Oh, that's a good idea. I like that.
I've got a little thing on the side there that Steve Steger was telling me that his wife was helping a friend to put some CuO GANS into the oil, into like a container of oil. She accidentally dropped the container right into the oil, and as water GANS mix, they said the water normally does not get absorbed by the oil, but it did. The plasma charged water absorbed the water, oil absorbed it.
Oh.
Yeah, it went bloop, all in one.
Yeah.
That's interesting.
I've got to do that yet. And just trying to understand what this is. And this plasma charged water did.
Is the water going to boil off when the oil gets hot? Which is going to rust the inside of your engine, if that's the case. With the car Magrav now that we're seeing a little bit, I think we're just a smidge less than 100%, a doubling of fuel mileage. When you're putting your GANS in your tank, if you get another 5%, does it matter?
That's right.
Is it really that important?
That's right. It's not worth it.
We're going to be moving away from internal combustion engines probably within the next 2 or 3 years anyway.
Right.
So if you do what you can right now, don't worry about the small stuff.
Yeah.
You're probably going to be better off. Now, if you want to experiment, by all means, experiment. If you want to try it, do one thing at a time. Dave was going to put the Magrav on the battery and coils on the spark plugs and stuff in the gas tank and then do his test. And I'm like, no, Dave, one thing at a time.
Yeah.
Then we can what actually makes a difference.
So can we go ahead and let Whitney do some coils here with you guys and just get your input on questions you had? I'm going to switch to speaker view, and if you can speak a little bit, because that'll pull the camera to you.
All right. So I just want to make sure that I've got this.
Look at yourself there to see what's in screen, but you should be, if you talk, you should be.
I really just, this is from your perspective. So to me, this is the front of the coil.
Can you guys see her showing as the main screen? Okay, because we don't see her.
So your A and your negative in and your positive out are all kind of on this side. So I have it reversed towards me. So your A, it comes in here, the energy, the small coil goes around again, loops up, goes around the big one, goes around again.
It does all that.
And then it comes down and it goes to the bigger, fatter coils, goes here, goes up and goes here, and comes out the end. Is that correct, Flo?
Exactly.
Wow.
Super duper. We're developing a whoop-de-whoop song. And a whoop. You know, because, yeah, we'll sing it. It'll be the new children's song, how to whoop-de-whoop gravitational magnetical coils.
Yeah, I mean, I don't even get this. These girls are like way out ahead of me. Right.
Yeah, it's a matter, the way it's wired is all 4 coils are wired in series. The 2 inner springs both flow in the same direction. The 2 outer springs both flow in the same direction, but opposite the inner springs.
Here. I'm just holding this up while you're talking. Just keep on talking.
And looking at the top, the wires where you'd be connecting to your maggrav should both be on the right-hand side.
Yeah. So if I'm looking at it myself, they're on the right-hand side, but since I'm turning it towards the screen, to me they look like they're on the left, but they're not. They're on the right-hand side.
No, that's perfect. It's exactly the way it's supposed to be.
And when I was showing, we actually just recorded a little bit of a video, so the video's correct. And we'll put that out. But I also, when I'm holding, I always consider this the front now, when I've got these to the right. And then I know which is the front and the back of the coil. And then also keeping, there's the ones that go through with the long tails. That's easy to make for people to see if they've got the one with the long tail bent out, or here. Napkins going everywhere. So here's the gravitational end that goes through.
Mm-hmm.
And I find from my perspective, if I'm looking at my coil, if I keep this on my left-hand side for both the big one and the small one, that helps me understand where I'm at when I'm trying to connect and find the connector too.
Sure. It's just when the coil is sitting flat and level, your outputs are on the right-hand side. And that's the top. If they're on the left side, the coil's just simply upside down. Turn it over and it's right.
I'll give you another piece of advice that helped me and John at their shop. We printed off the drawing that JT made, and the full page, we stick it up on the wall, and we lay it out on the counter. We make our markings on your left side, right side, magnetical, gravitational. You don't need to think over and over and over. It's there. Just lay it out, left and right, just like John was saying, or JC was saying. Make it really easy. Get a pattern laid out, a template. You follow that, and you make all kinds of it.
That's great, Don. And we have a video of you guys doing that too. Of John doing that with you guys in the shop. So that's in our kind of video catalog of shows that are up.
Kid, I noticed when she was going through it, you got to keep it straight. It's difficult when you do it over and over and over. Pretty soon you're gonna make a mistake. So it cuts out all the thinking. Just use the drawing that JT gave out. We use that every day. You can't get any simpler than that.
You have questions on the house unit? So we have any other tips on the car unit? And then Whitney has some questions on the house unit also.
Well, with the car unit, I'm going to be making up a drawing. I don't know when. I got to go shopping today, and Vivek's going to be building one too, and he was crying for a drawing, or complaining for a drawing. So I'm going to be making up a drawing for the car unit, but they are so simple.
Yeah.
I mean, all the information is already there. It's just a slight adjustment in the way you hook it up, and that's about all. So it won't be a really extensive drawing. It's going to assume you already know how to wind coils. You know how to hook up the coils properly. All that information is
You know, that would be wonderful, I think, to have that drawing, JC. So when you get it done, you know, share it with us, and we'll be our people. And you know what I'd like to say, just being out here teaching, is that we have, you know, people show up and it's just such a big jump in their minds to think about embracing all this stuff and incorporating it in their lives. But once you start doing it, it's not really that difficult. And so that's what we're trying to get across as we're out teaching, and get people to start, you know, putting it into practice and action. I mean, look at you, Jackie, with a whole new thing on your car, but it took you guys going to MIP Peru to really kind of get yourself out of the ballpark. And that's, you know, I think one reason we're out teaching on the road is so we can be with people in person and say, look, here, you can do this, and this is how you do it. And once we do something, it sort of like starts integrating. It's like taking a giant leap out of our whole old science system into a new comprehension, sort of.
Absolutely. Yeah. Yeah. Going to Peru definitely helped.
Well, having the hands-on, one-on-one, somebody looking over your shoulder going, yeah, that's awesome. That makes such a difference. Trying to assess it out for yourself. For me, in my situation, it's really easy because I've been doing this stuff my whole life.
Right.
But Cary, I remember some of the complaints that you had made when I was teaching you how to wind coils. And I hear them all the time. It's the same stuff. Just because they've never been there. Right. And then once you've done it, you go, why was I complaining? This is so simple.
Right. And you know what? The other thing is, I think it really is, I mean, once people start doing it, there's a shift that takes place. And I just want to encourage people to do it. And Whitney's thing that she kind of founded, called Many Hands for Peace, we'd like to see our groups that we go teach start having Zoom meetings or Skype groups, so that they can keep collaborating with each other. They can keep co-teaching each other and saying, I learned this, I figured this out, I'm doing this, this is how I'm doing it. And I may start a Skype room for the people that are the students in the different groups that we're teaching. So they've all got like an interactive place that they can, you know, because this is so great for us to be able to collaborate with you guys too, and just share knowledge and information, and then be able to pass it on.
Yeah, well, I think about it this way. You've got a really, really amazing scientist working on a project. We'll give his brain a value of 10,000. That's his brain power quotient. We got all of these regular folks who don't have quotients of 10,000. They're, 6,000, 7,000, 5,000, in around there, but there's thousands of them. Now, which is better? The one guy with 10,000 working by himself, or the 10,000 people with 2,000, 3,000 quotients all working together?
Right. Yeah. Absolutely.
I ran into the same problem. I had all the pieces made to make that hybrid battery capacitor with the 5 different windings, but I literally could not assemble it myself. I just couldn't. I don't know what it was, but I could not force myself to do it. And then, and Carolyn came out from Illinois so that she could learn how to do this. So good thing she didn't leave sooner than when she was going to, because we didn't get it done. Longer. But, there is a step to being together, to really helping each other with this. It's like we are expanding this genetic mind. And so you're going to get to some limitations, and then you just reach out for help. And everybody I've talked to has always been extremely helpful with whatever they can offer in the moment, So it's been really beautiful learning experience together.
Yeah.
Yep. Well, out of 6 billion some odd people on this planet, there are no 2 people that have the same talents.
Right. Yeah. Absolutely. And that idea of many hands for peace, many hands.
It's going to take us all. It's going to take everyone, Mm-hmm. And it's also everybody's ability in moment to put their energy towards peace. So even if they just sit and play with a piece of copper,
Right.
Well, look at the stuff that Libby's doing in Nova Scotia. She doesn't like caustic.
Right.
Scares her. She doesn't like it, so she doesn't use it. She nano coats in nature. She doesn't follow any rules. She just picks up a piece of copper and builds something and goes, wow, that's really cool. Nano coats it, and her animals love it, right? Yeah. It's not the shapes that we're making. Yes, the shapes have purposes, but it's the energy we put into those shapes that matter.
Right. Yeah, beautiful. So do you want to go ahead and talk about the power unit or the house unit?
Okay, so for the house unit, just to get clear, we've got 3 of these.
Mm-hmm.
We're going to connect our power, our live wire, to the negative in of the smaller.
Okay, the live wire from the wall goes to the bottom set gravitational.
I can write it if you want. You can talk.
Okay, yeah.
Say that again, JC.
You're going direct. I mean, is it the direct live wire from the walls?
Yeah.
Okay.
Well, your 3 coils are only the live wire.
Yeah. So it takes
finding that live wire inside the case. That's it. That's all it's doing.
We take a 3-prong plug and we find the live wire from the 3-prong plug that goes into the wall.
Yep.
And we pull that. Normally it's a black one, right?
In North America, it should be either black or red or blue, depending upon what phase you're on, right?
Depends on the color combination that you get.
Right. So then we can.
White is always going to be common. Okay, white is always common. Green is always ground. The live wire could be black, red, or blue. And that goes to the bottom coil to your gravitational of your bottom coil.
So then it goes through this coil, out this into the smaller coil, start again.
The magnetical of the bottom coil will connect to the gravitational of the second coil up.
Yep. Okay.
Right? So it's just series. In, out, in, out, in, out. That's it. Now, the capacitors, there's a number of different ways we can do that. We haven't found one that is the way to do it. So you can have 3 capacitors across the lines on your input, 3 on the output. You can have 3 on your input, 4 on your output. There's a number of different ways this can be done. And there is drawings out there in the Magrav blueprints. I think number 4, iteration 4 is the one most people are using.
We use number 5, so just, yeah.
Okay. Keep in mind, your capacitors are polarized. Okay, they have a gravitational and a magnetical as well. The pin is gravitational. So the pin goes to your live side, the coils go to the neutral. Always.
So Jackie, how do you have your 6 hooked up? Are they right in series or in parallel right to at the top there? They're all after the coils?
I'll show you. Let's look. 3 from the top, 3 from the bottom, and there's my pins.
Yeah.
Hold it up just a little bit more and talk to us so you go on live screen here.
Okay, so I have 3 from the top and 3 from the bottom.
And then where do those go? That's like...
They actually hook up at the very top. One of them's on a longer wire and it actually comes up, so maybe it's, yeah, I can't tell. Yeah, I think it's this way up. So basically, they looked really good earlier. Okay, can you see that now? So they basically connect, we got one at the top and then one comes from the bottom. And they connect at the top using this up here. So they actually go on there.
Hold that down a little bit. Yeah, there you go.
Yeah, I think with the current information that just came out, I think your capacitors are backwards. I think you need the pins on the coils and the coils on your neutral.
Yeah. Hey, I'm busy right now.
Or the pins on the Magrav coils. So you'd have your 3 stacks, and then instead of having the coils hanging there, you'd have the pins hanging there. And the three sets of coils would be separate, and they would go onto your neutral side. That's if I recall correctly, that's the latest information, because that maintains the magnetical gravitational relationship of the capacitors as well.
Okay. I know one of the things that was really strange, I have another one that was hooked up. I hooked it up in Peru, and funny enough, I hooked him up upside down and backwards. Did it work? Do them again. So yeah. Yes. Yeah. But, I do have one hooked up. If you want to see it, I can go get it.
Sure.
All right, I'll run and get it. You guys carry on.
Carry on.
Carry on.
Carry on.
So there's no thermal switch or something?
Not in the house units. The thermal switch is in the commercial units because somebody's going to plug a 5,000 watt heater into it.
Okay.
Right. And for liability reasons, we have to have shutoffs on that so that if it does happen to get hot, there's a safety. If you're building it yourself, you should know a little bit about this and not load it. Because you don't need to load it like crazy. You only need a couple of 100 watts on it.
Yeah. Do you use a power bar then as the load?
I use a fridge.
Oh, so you just
I've got one hooked up to my fridge, and I've got one sitting over there, which is driving all of the computer and sound system.
do you wire a power strip to it where you plug the fridge into it, or do you just have a direct outlet?
I don't have ones I can show you, but they're just replacement, big yellow replacement plugs that you can buy.
Maybe Jackie has it on hers.
No, hers.
Yeah, if I pull this one out.
Go ahead, talk, Jackie. Pull yourself into screen view here.
Okay. Yeah. Okay, can you see this?
Almost at the level of your face, you need to hold it up.
There you go.
That's good.
Yeah?
Yes.
Beautiful.
Does that help?
Somewhat.
You can also spotlight her video, Cary.
There.
How do I do that?
Click on her little window and click spotlight. You just have to remember to turn it off, because otherwise she's the only one that's going to show up in the recording.
Yeah.
There you go. I have a really good photo of it I can send you as well that I did before I nano coated. So it's a little clearer, and it was made up in the box, so it kind of looked, you know.
Okay, that would be great if you want to send us a couple photos. And do you have what your plug looks like?
Okay, so a little.
Oh, and it's marked for the live on this side.
Okay, and so the refrigerator just goes right into that, right?
Yeah, the refrigerator just plugs straight in.
Okay.
And there's my power cord, which is also marked.
Have you tried plugging it in yet?
No, because we had trouble with nano coating, and so now I'm trying to get the GANS ready so that I can actually paint the coils, because I finished nano coating, and then I'll be ready to plug in. So
awesome. Any more?
Yeah, and we actually had a demonstration of a failed unit. We did with Dave. We just did a test earlier this week.
Yeah, we saw that. That was cute.
Dave, he plugged it in, and the whole room lit up. And you know, things can go wrong.
I think it was on CNN, wasn't it? Terrorists in Peru. Yeah, it was pretty good. Yes.
But this is, again, the reason why that happened was he rushed it, and he missed a few things. He missed a couple of steps. So take your time. Don't rush this. You know, it's if it takes an extra day or an extra 2 days, don't worry about it. Take the extra 2 days. You're going to wind up with a better unit in the long run.
I'm so sorry.
Okay, it sounds like we're disturbing the place here, so we need to call an end to this video. So I guess we will say goodbye, and thank you so much.
She was. It's okay.
And we'll, yeah, good. And we'll catch up soon.
All right. Thank you. Nice meeting you, girls. Take care.
All right.
Thank you.
Many blessings.